Now, in the training objectives, we shall be talking about introduction to statistics, research designs, data types and data collection, data exploration and visualization, statistical tests, statistical inferences, parametric statistical test, non-parametric statistical test, survival analysis, experimental design, statistical modeling, multivariate analysis, and some of the softwares used for analysis. So make sure you watch all other videos also. Basically, statistics is the science of collecting and analyzing, interpreting, presenting, and organizing data set. There is a common slogan which always says, whoever owns the data owns the world. So data is very, very important, and therefore statistics is very important, whether you're a student or you're a professional person already working. Like, data is very important. For example, those in the business and economics world, you can use data sets to make predictions of customer needs, customer satisfaction, upcoming fashions and trends, so that you can be able to make reliable decision on which kind of products you can import or you can bring into your store. In people, in medicine and healthcare, you do use these statistics to evaluate, let's say, the performance of your intervention, your medication, your diagnostic compared to the control groups. In social science, you can use this study. For example, you can be assessing the psychological well-being amongst HIV positive patients, and you will need statistics for you to be able to draw conclusion. For people in environmental sciences, things like climate change, decrease in vegetation cover, all these require statistics for you to draw conclusion. Education, if you're a student and you're watching this video, one of the reasons for you to watch this video is maybe you're hoping to finish your research paper so that you can graduate. So therefore, statistics are very important. Quality control, for people working in industries making consumer products, it's always important to do quality control, and it requires statistics. So statistics is probably available everywhere, and it is very, very important. Now imagine you are then a student, a professional person, a data scientist, or whatever position you are in. Even you are your own boss. You have data set available. How can you make sense of it? How can you be able to then draw conclusion from it? So the next videos, we shall be talking about how you can make sense of every data set you're having, whether it is from your store, whether it is from your research, whether they gave you from class, from any kind of direction. We shall explore into details how you can make sense of that data set. In this video, we shall be talking about the fundamentals of the statistics, and there are three major fundamentals. Now, first fundamental is the descriptive statistics. We said after you're obtaining your data set, whether it is from your business, whether it is from your research, whether it is from a client, and they gave you a data set, what are the first things that you can do? Descriptive statistics remains very, very important step. Now, you can do analysis to summarize the data set in order to gain meaningful insight. That is descriptive statistics. So for example, you can see this graph on the right hand side. It is showing us a distribution of the data set they have given us. That's what we call a bell curve shape. Now in this bell curve shape, you can be measuring the mean, the median, or the mode of the data set that they have given you. So it tends to indicate a region of central tendency. So it's very important. But descriptive statistics can also be done in a way that you measure the variability between your data sets. Things like obtaining the range, that is the difference between the highest and the lowest point, the variance, the standard deviation, how far away are data points away from the mean. This generally shows the spread of the data points. It's very important for you to do this, because if your data set is widely spaced, widely spread, then you may need to do what you call normalization, which we shall cover in future videos. but it's very important to perform some statistical tests after ensuring that your data set is not very dispersed, like far apart. In descriptive statistics, you can also measure shape and distributions. Like, how is your data set distributed? If you plot it, is it bent to one side or it is in the middle? Now, the distribution that you can measure the plot includes the skew graph, skewness, test for skewness, or test for kurtosis. Now, you can present these things in a graphical format. And down below here, we can see so many graphical formats that we have presented in here. From the left-hand side, we have the tabular presentation, pie chart, bar chart, scatter plot, histogram, box and whisker plot, and then lastly, we have our skewness plot, our kurtosis plot. And we can see that plateautic in red, that shows that it's almost from a word plateau, like it's almost flat, like flat, it is not raised up. Can be mesochatic, meso from the word middle, meaning it is intermediate, and then leptochatic, that one are data set that do have very high variance between them. So you find that values or data points with very high values are also available, so it tends to form that kurtosis, that tall head. So it's very important to find out descriptive statistics, because if you know how your data is distributed, you can then be able to know whether should you do some normalization, should you do some elimination, or should you do any kind of transformation that you may need to do on your data set. But that alone does not give you or does not allow you to draw conclusion on your data set. Therefore, it is important to perform what you call the inferential statistics, that is drawing conclusion on your data set. There are several measures that you can do to draw conclusion. Number one, you can do hypothesis testing. This is where you evaluate whether the observed differences within your data set are statistically significant. We will talk about hypothesis testing in later videos within this series, so make sure you stick around. You can also do confidence interval, that is, you estimate the range within which a true population parameter is likely to fall. So if you expect that if you're doing a study in adolescent group, so you expect your study participants to fall somewhere within, let's say, 15 years, and then you're having somebody like 30 years, that is way much outside within the range that you'd expect your population to fall. So a confidence interval will give you that estimated range. It's much more clear and visible if you use a statistical software, which we will learn some of them within this YouTube channel, so make sure you subscribe and stick around. Then you can also do a regression analysis to arrive at an inferential or a conclusion. So this is where you examine relationship between two or more variables. For example, you can try to do a relationship between a person's education level and their income level. That you could do a regression analysis for you to arrive at that conclusion. You can also do analysis of variance. This is where you compare means of multiple groups of factors. Let's say you want to compare the CGPA of university students from first year to fifth year. So you'd have the average CGPA from first year to fifth year, and because you have more than two of those means, you then have to perform the ANOVA test for you to be able to check whether there are variations in between them. And then there are also other inferential statistics that based on assumptions. Those are known as the probability sampling and also the estimations and predictions. So in probability sampling, this is where you select a subset of individuals from a population so that they can be representative of the original population. So whatever you get from that sample population, you then try to predict, you then try to estimate that, okay, if we are done in the whole population, this is what would be the likely outcome. So that is all about inferential statistics. Now, it's also important to know that you don't stop there. There are other studies that may require you to use probability theory, or other application uses probability theory. So it's important to also know about probability theory, as it will help you and guide you in writing your research paper. So, probability theory. Thank you and welcome back to the channel. In our previous videos, we talked about the descriptive statistics, the inferential statistics, and now we're talking about a probability theory, which is the third fundamental aspect of statistics. So if you haven't watched the previous video, make sure you check them out. So in probability theory, studies so in this aspect, it studies the likelihood of an event occurring, and it tries to quantify the uncertainty. So it provides a framework for analyzing random phenomena and making predictions. Look, take for example this person on the right. You have always seen this person appearing on your screen. After watching news, then this person comes up and begin talking about the weather forecast. Now, they're using assumptions because they tell you tomorrow we are expecting rain. So it is like it's a probability. It's not 100% very, very true. Of course, it can happen or it cannot happen. Now, the rules in probability, and this is more like people who are into mathematics, you may less likely apply these things, but sometimes it can come around. Now, the two major rules in probability includes the additional rule and then the multiplication rule. Now, in the additional rule, we are calculating the probability of the union of two or more events. And those events has to be related to each other. So let's say we want to calculate the probability that someone is going to buy a piece of cloth after receiving their salary. So they receive salary, then they go and look for clothes and buy. Those are related. It is within the control of one person. That would require additional rule. What is the probability that you got your salary plus what's the probability that you are going to like this dress and buy? That is it. But in multiplication rule or in probability, that is when we are trying to get the probability of the intersection of two or more independent events. So let's say we have two people, Mary and Jane. They are expected to attend a same party together, but they don't know each other. They're living in different places. They even don't have each other's contact. So they do not know. So each of them are undergoing their own preparations and trying to go to a party. Now, it's really hard since no one is influencing each other. The chances of all of them being at the party becomes as much low as possible. Therefore, we will be multiplying those different probabilities, and it will end up giving us a much lower probability because the two events which we are predicting to happen are occurring at independent level. Now, you also need to understand other aspects of probability. For example, the probability distributions. And this is a distribution, generally like how the different probabilities are distributed. We will explore more once we come into real statistical analysis, but it can be binomial distribution, normal distribution, or exponential distribution. So there is also conditional distribution. This is where an event occurs when another event has already occurred. For example, what's the probability that you are going to carry an umbrella after seeing cloud getting like forming? In that case, the cloud has formed, meaning your probability of taking an umbrella is based on the fact that you saw clouds forming. But also there is Bayes' theorem. This calculates the probability of an event based on prior knowledge or information. Now, Bayes' theorem is applicable in so many areas, from machine learning to phylogenetics, algorithms, all sorts of things. But the basic principle is the same, that there is a prior information about something and then you try to predict. For example, if we want to predict the life expectancy of a person, then we shall do so many things. Which diseases do they have? What is their standard of living for now? All those kind of info. All that based on information we know about them, then we can then try to predict the probability that they will survive in the next 10 years, for example. That would become one of the applications of the Bayes theory. So that is generally all about the probability theory as the third fundamental in statistics. But even though you know some of these theory already now, it's important that you know how to design your research paper, which is why it's very important that you learn about research design. So whether you're a student or a professional person or in any category you are in, it's important that you know how to write a research design. It's very core, very fundamental, as it entails all the strategies and the guides that you need during the process of you collecting or conducting your research. Now, there are so many key points within research design. You need to be able to identify. After you know your topic, of course, you should ask yourself, what are my purpose and objectives? That's a very important key point under research design. What are my research questions and hypotheses? You should brainstorm and answer that question. What is my type of study? How about the sampling strategy I'm going to use? Which variables and measures am I going to measure? What are the data types I'm going to collect? Which data collection methods am I going to use? Because each of them do have strengths and weaknesses. How about data analysis methods? How about the ethical considerations? How will I ensure that my participants' life is not at stake? And how about the limitations and how I am going to combat those limitations? So it's really very important that you answer these questions very carefully. Now, because it's an important aspect of research, we are going to dive deep into each and every most important aspect of it, the ones which are tougher to understand. It's very important that if you're writing your research design for either your school paper, your organization, for any purpose, it's important that you know the type of study. So types of studies are very important. Now, there are three divisions of types of studies. Of course, under them, there are again subdivisions. But majorly, you have the observational studies, experimental studies, and meta-analysis. Observational studies. These are studies where you analyze and observe subjects in their natural settings. So your main purpose in this case is to try to describe the relationship and try to identify patterns amidst the participants or the population in their natural setting. So examples of those studies can be cross-sectional studies, the case control studies, or the cohort studies. We shall explore these ones in a future video, so do not worry. Now, you can also do experimental studies. Now, this is where you manipulate the variables to determine the cause and effect relationships. Now, here you do assign participants different groups. For example, that's applicable in randomized control trials. Let's say you're doing a drug trial or a diagnostic kind of research. You may need to then do an experimental study. There is meta-analysis that I've added here. It's getting common. So this is where your researchers go and collect findings from many other scholars, and then they come and combine and report it as one single paper. Now, let's dive deep into some of these research studies, different types of studies, into details. Now, whatever study you're doing, it may fall within one of these categories, and you should always be able to ask yourself, which category does my study fall? Is it a longitudinal study? Is it cross-sectional study? Is it a retrospective study? Is it a prospective study? Is it a qualitative study? Is it a quantitative study? Or it is a mixed study? So it's really very important. Now let's dive one by one. In a cross-sectional study, if your study is cross-sectional, you must be able to gather data from your specific population at a particular time. One time without follow-up. So when you go in a community A, interview people, get information about them and go away, and you do not follow them up, that will become a cross-sectional study. But if you go to that place A, and then after 6 months, you go back to that place A again to talk to the people whom you talked to at your baseline, at screening, at the time you began the study. Then after 2 years, you go back and again check on them. that becomes a longitudinal study where you follow participants over an extended period of time. Then you can also have a retrospective study. So this is where you look at the records or the data set of many years ago, and then you can draw conclusion from that. That will become a retrospective study. So let's say you go and get lab results that they have been reporting for the last 10 years, and then you want to analyze and then report. That becomes retrospective. And then there is prospective studies. In these studies, individuals assess the occurrence of outcomes. Okay, they collect data on exposure and track participants. For example, a disease outbreak. For example, COVID-19. We followed up COVID-19, the infection rate, the transmission rate, recovery rate. That was a prospective study. So you should be asking yourself, where does this study fall? Then you have qualitative versus quantitative. Qualitative studies, those are studies where we are collecting non-numerical data. For example, in interviews, when you ask somebody and then they just verbally give you information, that become qualitative. There is no numerical data attached to them. But if you ask somebody that, okay, how much did you make last month? Okay, what is your CGPA, please? Okay, how much does that car cost? Those will become quantitative because they are giving you real values, real numerical values. Now, there are those studies that can combine both the quantitative and then a qualitative approach. Those are called mixed studies. So in mixed studies, we are saying that you collect two types of data. For example, you may want to check out the performance of university students based on their CGPA. So CGPA would be numerical data. Then again, you'd want to further go ahead and find out what are the likely reasons for the observed CGPA by interviewing them. Then when you interview them, they will give you non-numerical data, which is qualifies for qualitative. So that will become a mixed method. Now, as soon as you have identified the type of method that you want to use in your study, it's important, therefore, to get participants, and you should know which method you will use to sample participants. So this video we shall talk about sampling techniques. It's important because once you're going to do your research, whether you're going to recruit participants or you're going to use secondary data or whatever thing you are doing, you will need to do sampling. This is where you only pick a portion from a population, some people from a population, some data set from the whole data, so that they can act as representatives. Why? You may not be having the resources to do study amongst everyone. Two, you may not be having the time. So sampling is very important amongst some other reasons. But also it's important to identify the type of sampling method you are going to use. Each of them do have strengths and weaknesses, and each of them do have areas where you can use them. One type is random sampling. So your sampling techniques can fall under random sampling, stratified sampling, cluster sampling, convenience sampling, purposive sampling, snowball sampling, and that. Now, what does each of them mean? In random sampling, this is where each member of a population has an equal chance of being selected for the study. If you go a class of 100 people and you want to pick 10 people randomly, everybody by that time will be having an equal chance of being selected. Now, in stratified sampling, when you divide populations into subgroups, or what is called sometimes strata due to a given characteristic. Let's say you want to do a study, you are trying to compare the stress level between males and female students. In that case, you will have to divide male alone and female alone. So that type of sampling is called stratified sampling. Then we have the cluster sampling. So this is where you divide populations in clusters or groups based on geographic or other characteristics. So let's say you want to compare the income level of people living within town versus those ones living within villages. You then have to cluster. You then have to cut. Okay, for you are within town. Okay, I'm going to recruit you under town. For you, since you're in the village, I'll recruit you under the village participants. In that case, because you have divided your participants due to the geographic region or due to other characteristics, in that case, that would become a cluster sampling. This photo can show us here that in stratified sampling, everybody who is red, everybody who is male, grouped alone, females, grouped alone. In cluster sampling, no, we are using other characteristics to cluster our participants. Then there's convenience sampling. This involves selecting participants who are readily available or they are easily accessible. If this is mostly applicable in case your prospective participants are fewer. So let's say you want to do a study amongst mad people on street. Those people are fewer to get. So you cannot go and begin randomly sampling. No, you just have to use the person who is available and you see. Then we have the purposive sampling. Purposive, from the word purpose. So this is where you deliberately select participants who meet a specific criteria as per your study. So let's say you want to do a study on domestic violence amongst HIV patients. It is just ideal that you have to look for HIV patients first. Then you can assess domestic violence amongst them. That would make very logical sense in that case. So in that aspect, that will become a purposive sampling. Then there is snowball sampling. In snowball sampling, you must identify initial participants who meet your study criteria, and then you ask them to refer other potential participants. Now this is common in scenarios where it is very hard to identify participants. One of the projects that I worked with one of the clients, we are trying to assess the impact of Facebook marketing on the consumer purchase decision for those ones within my country. Now because Facebook is broad, it would be very hard to really screen. It would be hard for me to screen out who is from my country. So we decided to only look for a few participants within Facebook that we are sure that they are from Uganda, and then we ask them to share our questions with those ones that they are their friends and they're sure they are from Uganda. So that was snowball sampling, and it was very successful. Now, even when you have sampled your participants, the question therefore remains, how will you measure their responses? How? So you need to know which scales will you use to measure their responses. So let's talk about the measurement scales. So measurement scales, these are used to categorize variables based on the nature and the properties of their measurements. Now there are four major measurement scales. One, we have the nominal scale, ordinal scale, interval scale, and ratio scale. Nominal scale, these are kind of scales that measure categorical variables, measure things in terms of categories or distinct groups, male, female, okay, big, small, categorical variables. Then we have the ordinal scale, from the word order, arrangement, ranks. So this one ranks variables in a particular order. Let's say when I ask you what is your education level, you're going to tell me primary, secondary, university, PhD. Now, because of that rank, that will become an ordinal scale kind of data set. Then you have what we call the interval scale. Now, interval scales, these are variables on a scale with equal intervals between them. Like a Likert scale. A Likert scale. Like very satisfied, satisfied, neutral, less satisfied, very less satisfied, or dissatisfied. Like that become a Likert scale, that kind of arrangement. Then lastly, we have the ratio scale. Now a ratio scale, these are values that do have true 0 points. For example, in other words, both the magnitude and the relative differences between the values are meaningful. For example, a person's income, if you want to then do a balance sheet, there is income, there is expense, so you have to subtract those values. So you can have even 0. When the person's income and expenses are equal, then the person will have 0 balance. So 0 will make sense that, okay, this one now has no money. Or even negative, be like, okay, this person is in debt now. But in other scales that we have talked about up there, it's hard. For example, interval scale. Now, if you have measured a person's response in interval scale, like in a scale of 1 to 5, how satisfied are you with our product? Then somebody says 4, and then another one says 1. If you get the difference between those responses, It doesn't make, you can 4 minus 1 does not make sense. Like it's like at scale, like it doesn't add up. It doesn't make sense at all if you try to subtract. That's a clear difference between the interval scale and ratio scale. Ratio scales, there is true 0 points, and those points are even meaningful. Interval scale, not true 0 points, and even it's hard to make meaning out of them. Now, even though now you know how the scales, how if you design your questionnaire, the scales you can use depending on your study objectives. Now, which kind of variables must you collect? Which kind of data must you collect? How do you know this is independent or dependent variable? And what are they even? What are even variables? So there are two types of variables majorly. So you have the independent variable and then the dependent variable. Now, independent, those are variables that can be manipulated or controlled by the researcher. So it causes prediction. It causes a predictor to change. It can be called a predictor. Let me give you an example. If the outcome of interest is promotion, job promotion, the question is, what can make you be promoted? Okay, higher education qualification, higher experiences, good performances. So those those would become independent variable. Then you getting promoted would become dependent variable. Dependent, those are variables that is observed or measured to assess the effect or the outcome. So it is the effect or the outcome variable. So those are the two main categories. But as you deep dive into research design and research writing, you may come across other types of variables like confounding variable. You may hear about it. So those are variables that influence both the independent and the dependent. Okay. Let me give you an example. Let's say a person's geographical setting. You may find it can influence both a person's income level or even them getting promotion. If the person is in a village, they are less likely to get promotion. Their income will more likely be lower compared to somebody who is in town. Now, that would be a confounding variable. In my opinion, there are also mediating variables. Those are variables that do lead into occurrence of a particular outcome of interest. You can read more about it. They have the moderating variables. They're also there. They have the quantitative and the qualitative variables that we have really talked about within this video series. Sometimes they can be referred to as categorical versus numerical variables. Some of these terms tend to play back and forth. Quantitative goes with the numerical, quantity, numerical. Qualitative goes with the categorical. So they tend to play back and forth. But at the end of the day, the most two are independent variables and dependent variable. Now that you have learned about variables, the question is, after you now knowing all the things, designing the sampling method, you have gotten sample size, you have gotten all the measurement scales, you have gotten the variables you want to measure, how then can you collect data? What are the different sources of data? Now, the two data sources, you can either have primary data sources or secondary data sources. Now, in primary data source, that is where there is need to measure or obtain data. You may have to go to the field if it's a cross-sectional study. You may have to go and set up an experiment in a lab if it's an experimental study. That is primary sources of data. But another source of data can be secondary sources of data. This is where the data set is already available. All you have to do is to go and retrieve them. With the secondary data sources, you can have two other sources under it. Can either be internal sources or external sources. Now with the internal sources, this is where you have data set coming from within, let's say a given company or a given school. For example, data on customers, data on sales, data on finances for a given company, that become an internal data source. But you can also have an external data source. This can be like from the internet, let's say data on inflation, GDP, all these other kind of sources of data. That could be another form or another source of your secondary data, external data set. So here we can easily see how from these different data sources here, the question is, how can we then collect based on the type of data we want to collect? What are the different data collection methods that can be used? There are so many types of data collection, and they do depend on the type of data you are trying to collect. Are you trying to collect primary data, or are you trying to collect secondary data? So thank you so much and welcome back to the channel. Today we're talking about data collection method. Now, if you're collecting primary data set, that is data that you must just record there and then in real time, in real place. One, you can use statistical methods for you to obtain those data set. There are methods like the Bayes theorem that can estimate or predict for you some data set based on what is already known. So you can generate primary data set based on what's already known, like, so that you have sort of a primary data set. You can use surveys. That's why you go and then you survey people. You can use polls, you can interview people, you can use the Delphi technique, you can use the focus groups technique, and then so many other methods which are not talked about here, especially under experimental designs. If you're doing lab work, hands-on, all those could fall under the primary data collection methods. Now, how about the secondary data collection methods? So in case you want to use records, where can you get those records from? This can be financial records, sales report, government reports, missions, vision statements, the internet. There are so many ways that you can always get this secondary data set, and you can use it for your study. So depending on which kind of study you are doing, then you may just need to consider one of these data collection method. Is it primary, or you're doing secondary data? And then you can just pick one of these methods and use the ones which are applicable. Even after finishing to collect your data set, the question now remains, how will you make sense of it? Well, whether you got primary sources, secondary data set, no matter the ones you got, it's important that you know how to do the analysis. And the first step to do analysis is to do exploration data analysis. So this one involves examining and visualizing the data to gain insights, identify patterns, and understand the underlying structure. If you watched one of our earliest videos, we talked about descriptive statistics much earlier on in there. This is one of the form of descriptive statistics. So we are just getting summaries: mean, median, mode, standard deviation, variance, range, generally distribution, normality test. That's what we are doing at this exploratory data analysis. And we can present its result in terms of graphical format to check, is it normally distributed, is it skewed? It's important to do that exploratory data analysis. And why would you even need to do that? Why is it important? It's because, one, is you not only check for distribution, but also you can be able to identify missing data, and you can be able to make judgments how you can handle those missing data. In our future videos, make sure you check around. We shall talk about how can you handle missing data. We'll talk about the mean imputations, the mode imputations, the elimination method. There's so many methods that we shall talk about. So make sure you subscribe and stick around so that you know all these basics. Now, doing data exploration also allows you to detect outliers. That is when you're having these values that are very far away from others. Like, it can really cause your data set to be really much skewed. So it's important to detect those outliers so that you can either eliminate them or you look for a way of transforming them to let them fit within your required range. You can also obtain relationships and correlations You can, if you do cross tabulation, like a chi-test sort of, that can also be put under data exploration. You can try to check relationship between the different variables which are under investigations. At this stage, you can do also data transformation. In case you find that your data is not normal, highly skewed, sparsely distributed, you can do normalization, or you can even do further cleaning like elimination in case you have like very, very high values that are very varying, or you have missing data sets. You can eliminate some of those entries. Or you can do standardization or log transformations. We may talk about these, we shall talk about these in later time, the different transformation techniques. Now, there is also feature selection. This is where you identify only relevant features or variables that are most influential or informative for the research question. There are some other variables that you may collect which are not important. For example, participant's ID. Participant's ID cannot be informative in any way. Some of those you have to eliminate them under the data exploration analysis. Now, during this stage, you can also generate hypotheses, especially if you're using secondary data. You may need to first obtain the secondary data first, and then based on your data, you can then work backwards. Which hypothesis can I draw from here? Which objectives can I get from here? Which title can I get from here? And then you can work backwards in that other case. Now, in data exploration, it is important then to do data visualization. Data visualization is very, very important for every researcher, every student, every company, everyone. It's important that you visualize your data set because, one, it is very easy for a layman person to interpret. It's even very easy for you to interpret. It offers summary for everything. It allows you to, within just an instant, easily recognize or draw pattern within your data set. So it's very important that you know some of these data visualization techniques. It's very, very important. So you have the pair plot. That is where you are plotting two variables per time. This is much more common in machine learning. We shall do some machine learning within this channel. Make sure you stick around. So where so you plot two variables per time to check at the correlation in between them, so that you can see if they're too correlated, you may need to eliminate them. It may affect your machine from learning well. You can also do the bar charts. So bar charts are common in categorical variables, males, females, low, high. You can always use bar charts to see the distribution of the people. Box plot is also based in categorical variables, though for it can tell you some median, position, mode. It can tell you some other information. It can even tell you sort of, would I call it confidence interval, like the lower and the upper, based on those. So it's also important. You can also do a scatter plot. This one is where you are plotting numerical values, preferably as x increase, y increase or decrease, just trying to predict how influence of variable A influences the outcome of B, something like that. You can also do pie chart, either frequencies or proportions, that's percentage. You can do line chart, for example, measuring temperature, cumulative temperature, or rainfall accumulation per year. You can also use a line chart. There's area plot, x-bin plot, histograms, heat map. It's a very nice plot we shall explore once we come to Excel and R statistics. It's very important to show a correlation or between two variables. Correlation, association. It is very, very important to use a heat map. It's a very good one. It's a very, very good one. So yes, so it's really very important to know some of and there are so many other data visualization techniques that you may need to explore them out. Now all these are still under exploratory techniques once you have a data set. But still the question remains, how do you draw conclusion? How do you arrive at the final conclusion that this is how my results are standing. After you collect your data, for example, okay, this is where I stand. How do you infer? Statistical inferences involves drawing conclusions and making inferences about a population based on sample data. If you have your data set, you have a data set, you want to draw conclusion, that's the point we talk about the inferential statistics. And we hinted this on our second or third lesson on this video series. If you did not start from the beginning, you may need to go back and watch the whole of the series. You will learn a lot along the way. But we talk about hypothesis testing as one of the measures for you to infer. In hypothesis testing, it's used to make decisions or draw conclusions about a population based on sample data. It involves formulating a null hypothesis and an alternative hypothesis, and then you perform a statistical test to either reject or accept that hypothesis. I gave an example sometimes back, but let me give another example today. If you want to assess an association between maternal health and family income, for example, your null hypothesis would be null, no, nothing. Your null hypothesis would be there is no relationship, there is no association between a person's maternal health and their family income level. That would be null. So null hypothesis says that there is always no association, no relationship, no. So every time you are stating your hypothesis, make sure if you're dealing with the null, then you are talking about no association. If you're talking about, and the alternative is vice versa. The alternative hypothesis in this case would be there is an association between a mother's maternal health and the family's income. But generally in research design, research studies, we tend to only write one hypothesis because we need to reject one. So writing one, since the other one is the opposite of the other, we just write one. But in most cases, people prefer using the null hypothesis. So that's one way you can arrive at a conclusion if you have a data set. But you need to run statistical analysis using those softwares, and we shall learn some of them within the channel. So make sure you stick around. I have a lot of plan for this channel. Now you can also use confidence interval for you to draw conclusion. So confidence interval, it provides a range of values within which the true population parameter is likely to fall with a certain level of confidence. So we shall explore this with the time, that some values must fall within the confidence interval. When we do things like regression or even regression analysis, those logistic and the logistic regressions and the Poisson regression and a number of those other statistical tests, your outcome, like your odds ratio or your incidence ratio, needs to fall within a given confidence interval. If it falls outside, it's even highly impossible. But if it falls outside, that's automatically what you you failed the analysis. It's a very important test in that case. Another measure for statistical inference is p-values and significance levels. P-values. A p-value is used in hypothesis testing to decide whether to reject the null hypothesis. So it is based on a significance, either 0.05, 0.01, 0.001, something like that. Now, this one we shall explore much into details about p-values. Most people do struggle understanding them, but that's a probability of the outcome of interest falling within the required range or the required probability, and most of them lies between it's 0.95 averagely, but comes 0.95 you need to fall within there, or 0.90 in case it's 90% interval, or 0.999 in case it is a 99% confidence interval. So in case you fall outside like that, so let's say you're less than 0.05, less than 0.01, then that will become a very significant finding. Now, it's also important to talk about the type 1 and the type 2 errors. Now, these are errors that comes about when you either reject or accept hypothesis wrongly. And it's one of also the basis for statistical inferences. So type 1 error occurs when the null hypothesis is rejected even though it is true. And this is mostly they do arrive when you perform a wrong statistical test, you use the wrong statistical method, and so you can get an error. Or a type 2 error, this one occurs when the null hypothesis is rejected even though it is false. Again, all this would come from which statistical analysis did you use and how did you arrive at your final conclusion. Now, the most important aspect of arriving at a conclusion about your data set is statistical tests. You need to perform statistical tests for you to get those p-values, for you to then either accept or reject your null hypothesis. And some of the statistical tests can include the t-tests, the chi-square test, ANOVA test, regression, or some non-parametric tests like the Wilcoxon or Mann-Whitney U test. There are so many other statistical tests. So we will explore in this future video some of these statistical tests. So statistical tests. In the previous video, we talked about the statistical inferences, and we said that if we want to arrive at a conclusion about our data set, then we need to perform some statistical tests so that we can either be able to accept or reject our null hypothesis. So mainly in statistics, there are two main statistical test categories. We have the parametric test, statistical test, and then the non-parametric statistical test. Now, these are the differences. In parametric, it assumes specific distributional assumption about the data, but in non-parametric, it does not assume specific distributional assumptions about the data. So, in parametric, there is an assumption. For example, for example, it's expected that the distribution is normal distribution. So that's the assumption made. But in non-parametric, they do not make an assumption. In parametric, it also requires estimation of population parameters. Okay, estimation. So yeah, because you need to be having full data set and all that for you to be able to have a normal distribution. But in non-parametric, it doesn't require any estimation. Deal with what's available at hand. Also, now in parametric, it makes assumptions about underlying population. There are so many assumptions, we have already talked about it. But in non-parametric, we have talked about it, doesn't make some of those assumptions there. Now, in case the distributions are made, that is normal distribution, then parametric would become much more powerful. But either way, all this depends on, first of all, what is the type of the data set you're having, what is its distribution in terms of a normal distribution, okay. And then from that, you can begin figuring out which kind of test are you going to use, depending on which method or what objectives you are trying to answer. Now, we are going to dive deep into the different examples of the statistical tools, statistical methods under each of these tests. Now, if you want to compare mean between two independent groups, for example, if your research question is, do managers who are men have a higher average salaries than managers that are female? Those are independent groups. If the data set is parametric, let's say a normally distributed, filled up, like all those assumptions are made, parametric test, then you would do a 2-sample t-test. A 2-sample t-test. If those data set collected did not meet the assumption for a for a parametric test, then you do a non-parametric test for 2 samples, mean that would be Wilcoxon rank sum test. Now, next scenario, when you want to compare 2 quantitative measurements taken from the same individual, same person. For example, you want to examine students' diagnostic test results before and after a study. If the dataset is parametric, normal distributions, all those other assumptions we talked about have been met, then you'd do a pair t-test. But if some of those assumptions for parametrics have not been made, then you are going to do a Wilcoxon signed rank test. Next scenario, if you want to compare the means between 3 or more independent groups, for example, is there a difference in the crop yield if a farmer uses fertilizer A, B, and C? If the dataset collected is parametric, then you are going to have analysis of variance, or what you call the ANOVA test. But if the dataset collected is non-parametric, then you are going to use Kruskal-Wallis test. Next, estimate the degree of association between two variables. If you want to estimate the degree of association between two variables, for example, does the number of hours a person spends on social media affect the number of hours they sleep at night? Okay. Association between number of hours spent on social media versus the number of hours which are spent sleeping at night. If the dataset collected is parametric, assumes the normal distribution, like all those other factors have been, conditions have been met, then you would do a Pearson coefficient of correlation test. But if those assumptions are not met, then you are going to do a Spearman's rank correlation test. So this is how important it is. This is sometimes referred to as a decision tree in statistics. If you have your data set, how do you arrive at the decision on which statistical method to use? Or if you're designing a research paper, how do you then decide on which statistical method you later use to analyze your data set? This is very important for you to know. Now, we are going to dive into some of these methods, some of them that we can dive into. We shall dive into some of them, like the correlation, regression, some of them that are very, very common. We shall dive into them and we try to talk about them. If you want to assess association, relationship between two variables, then it is important to do correlation and regression analysis. Now, in correlation, it measures the strength and the direction of a linear relationship between two continuous variables. For example, if you want to check the correlation between temperature, okay, of the weather, let's say the daily temperature of the weather, and then ice cream sales, okay, you know that if the temperature of the weather is higher, people will buy something colder so that they cool their body. Now, if you want to check that relationship, then you'd do a correlation analysis. But remember, correlation does not imply causation. So it doesn't tell you the cause. It can only tell you association between two variables. For example, you may have a positive correlation. This is when change in one affects the other positively. For example, increase in temperature results into increase in ice cream sale. That's positive correlation. Negative correlation. Increase in harshness of a teacher results into decrease in student marks. That's negative correlation. Then no correlation, like if there is no pattern at all. Increase in this does not even cause a change in the other one, so there is no pattern at all. That will become a no correlation. So that is correlation, generally how it is applicable in statistics. But how about regression? Now, in regression, it's divided into simple linear regression and multiple linear regression. Now, in simple linear regression, these are models. It models the relationship between one predictor and one outcome variable. For example, if you want to predict a student's performance based on the study hours, student performance, that is one dependent outcome variable, based on study hours. Hours studied, that is independent variable. So those are only two. That become a simple linear regression. But if you want to determine multiple effect on a predictor or on an outcome, then you'd want to do multiple regression. For example, if you want to analyze the influence of age, gender, education on job performance. Now, because you have age, gender, education amongst others as the independent variable and only job performance as the dependent variable or the outcome variable, then in this case you are going to use multiple regression. In this picture, we can easily see in simple linear regression, we're saying we have time. Is time associated with the money, amount of money? Does it influence money, amount of money? That's simple. One variable per time versus the outcome. But here we are seeing in multiple linear regression, we are saying education level, time, and your health. How are they influencing your income? How are they influencing your income here? So that is what this picture is trying to represent. Now, something bonus that you have to really look into is what are univariate, bivariate, multivariate analysis. So welcome to this video. In this video is going to be a short one. We only want to talk about univariate analysis, bivariate analysis, and multivariate analysis. In univariate analysis, this is where you analyze each variable in the data set separately. For example, analyze height of students, analyze the gender of your participants, analyze the age group of your participants. That would become a univariate analysis, and we majorly use descriptive statistics. Bivariate analysis. This is where two variables basically look for possible association between them. So you're analyzing two variables and look for association between them. They are commonly used in inferential statistics, that is either rejecting or accepting the hypothesis. So for example, let's say you want to look at the influence of a person's health status on their debt level, or the influence of amount of food eaten by a child on their weight. That becomes bivariate analysis. Then we have the multivariate analysis. This is where you analyze more than two variables to look for possible association on the outcome. Now, we already looked at some examples sometimes back, but age, for example, you look at age, a person's health, a person's education level. How does it influence their income level? So that will become multivariate because you're having many independent variables being considered and trying to see how it predicts the outcome or the dependent variable. Now, the above is important in handling the confounding variables. So multivariate analysis is really important in handling confounding variables. Confounding variables, these are variables that do influence both the independent and the dependent variable. They are very, very important. And sometimes if you do only a bivariate analysis, it can show you significance, but if you do multivariate, it will become insignificant. So that is how important it is to do multivariate analysis. In fact, it's much more preferred if you run both bivariate and multivariate. It's preferred that you do report the multivariate analysis because it is much more accurate. Survival analysis. This is a statistical method used to analyze time to event, such as the time until an event occurs or the duration of survival. Now, majorly commonly, there are three main survival analyses which are conducted by researchers. Can either be the Kaplan-Meier survival curve. This one estimates the survival function over time. Okay. Can either be the log rank test. This one used to compare the survival curves between different groups or treatment conditions. Okay. And then you have the Cox proportional hazard regression. This is used to analyze the relationship between multiple predictors and then the survival time. So this is mostly in people who do survival analysis. So that is it. Kaplan-Meier survival curve. Over time, do you survive? Okay? Over time, if we give you time, what's the survival rate, keeping all other factors constant? In log rank, we are saying, okay, if we have the control group and then a treatment group, or treatment group A, treatment group B, what is the survival rate at the end of the day? We do the log rank test. And then the Cox proportional hazard, we are saying, if we have a given patient A, how many other diseases are they suffering from, and what is their likelihood that they will survive compared to somebody who is suffering with this and that disease? So that is how you can draw a comparison. So that is all about survival analysis. If you're into that area, you can read more, explore more, or you can send me a question, email me, and then we can talk. In this video, I want us to talk about experimental design. This will be much more applicable for people who will either be doing field work, clinical trials, health-related stuff, and even social sciences. Psychology. It's really applicable also. Now, in experimental design, these are type of studies where you can manipulate the variable so that you can see its effect on the outcome or the dependent variable. And there are so many types. The first type is randomized control trials, then factorial designs, and then blocking and randomization. Let's talk about the randomized control trials. Here is considered as the gold standard for evaluating the effectiveness of interventions. So you have participants, randomly assign them study groups. Either you're going to be under experimental group, or you're going to be under the control group, so as to minimize biases. Now you will be testing new drug by randomly assigning participants to receive the drug or a placebo. So mostly in drug trials, just divide people into two and then treat them with your drug of interest, while the other people either don't treat them or treat them with the non-drug, and then you observe the difference in the performance. It can also be factorial design. In factorial design, this is where you study the effect of two or more independent variables simultaneously. So the benefit is that they allow for examination of main effects and then the interactions between the variables. So let's say you want to investigate drug A and drug B, like how this gentleman is doing. You can just divide your population into two. Treatment A, treatment B, subject them to the two drugs, and then observe their effect at the end of the study period. Now we also have the blocking and randomization. Now this is where you block or you stop or you prevent a certain group of people, or you eliminate them before you go ahead and divide your participants into control and experimental group. For example, let's say you're trying to research a given drug and you know it may affect pregnant mothers. Then it's important that during your clinical trial, first eliminate the pregnant mothers, and then you can do your trial on the other remaining people. So that is the blocking and randomization. So those are the three main experimental designs that you need to know. Now in this video, we're going to talk about statistical modeling. Now this is a powerful technique which is used to analyze the relationship between variables and making predictions. Yes, relationship between variables and making predictions. The most common one that we know is the logistic regression. So this one is used to make predictions on the outcome variable if it is categorical. So logistic regression is used when the outcome variable is categorical. So it predicts the probability of an event occurring based on the predictor variables. So you'll always see it reporting things like the coefficient versus the odds ratio, depending on what you exactly need. We then have generalized linear models. Generalized linear models, they extend regression models to accommodate various types of responses variables, including counts and categorical variable. So it's more like a modification of regression model. Now the use is that they do allow for modeling relationships between predictors and responses variable with different distributional assumption. Now, for example, when you model a number of customer complaints based on customer satisfaction rating, okay, and generalized linear models are reported in terms of incidence risk ratio. This is also sometimes known as the Poisson regression. It's a similar thing. Then another statistical modeling which is important to know is the time series analysis. So this is where you focus on analyzing data collected over time to identify patterns and make forecasts. So you can use this in economics, weather, finances, etc. Like how we are seeing here, we have always seen this, especially with the cryptocurrencies and all these other currencies. Okay, so you're using data and then collect over time, and then you try to predict where or what the trend is. So it's a very, very common one, and even much more applicable within our setting, day-to-day life. So there are also other areas you may look at. You can look at the multivariate analysis, such as the PCA, cluster method, factor analysis, MANOVA, multivariate regression, decision trees, and then some data analysis software. So that is all for this video and for this video series. Welcome to the end if you followed up to the end. If you didn't follow up to the end, make sure you watch from the beginning, or I'm going to provide the compilation of all the videos for this series so that it is one and you can watch it from the beginning until the end. Thank you so much. Make sure you like the video, subscribe to the channel so that you do not miss out. I have a lot of plans for you. Give me your questions, put them in the comment section, or send me an email. See you all.